Our generation faces incredible challenges. We are exhausting the Earth's non-renewable resources. The planet is warming up. Whole ecosystems are changing and collapsing because of the way we consume, because of the materials we use in our daily lives. To make matters worse, the materials we use don't degrade well. Our waste lingers in the environment. But our generation also sees incredible opportunities. Through chemistry, we have the potential to change our economy, to make it more sustainable, to make it circular. Changing the materials we use and how we use them is an essential part of that future. This means we need to transition from an oil-based economy to an economy built around bio-based materials. Our current economy heavily relies on non-renewable resources. For instance, we increase overall atmospheric carbon dioxide levels by extracting and combusting fossil fuels. Apart from the fact that these resources will one day deplete, we are also disrupting the natural carbon cycle and accelerating climate change. What is our alternative? Biomass can be used as a raw material to produce chemical building blocks and advanced and sustainable bio-based materials. Biomass can range from crops and trees all the way to sewage and other waste streams. It's defined as material of biological origin, except for materials which are embedded in fossils and geological formations. The carbon contained within these raw materials was already part of the biogenic carbon cycle, the total amount of carbon cycling between the atmosphere and the biosphere. Therefore, their environmental impact is much smaller. And most importantly, biomass is renewable. It is the main resource to create bio-based materials from. Examples of such products include starch-based packaging materials, edible food preservation materials like chitostan films, and implants made of polylactic acid derived from plant material. While these materials are a great start, transitioning to a sustainable future also means we need to think circular. A material's environmental impact doesn't end when it becomes a product. The way a product is broken down or reused as a raw material at the end of its lifespan is equally important to consider. One of the program's founders, who will tell you where they think the field is headed.
There are a lot of developments going on in the field of bio-based materials. It's a relatively new field and a lot of researchers are working on it. And now you see that more and more products are also entering the market. So technologies have been upscaled and companies are shifting to bio-based materials and use different resources for the materials. So that's also important for the future, because currently bio-based materials are about 2% of the materials are made of renewable resources. And I think the coming years this percentage will increase. So more and more materials on the market will be based on renewable resources. On the other hand, we see also a development towards circularity. So when we discuss bio-based materials, we focus a lot on the resources that we use for the materials. But the past years also the end of life of materials has become important. So after use, what is happening with the material? How can we improve the sustainability of materials by designing them in such a way that they can be recycled after use?
To summarize, bio-based materials pose exciting and critical challenges. They require a new generation of scientists with an interest in sustainable solutions for materials challenges. These scientists should be able to think outside of the box and to learn, communicate, and work across disciplinary boundaries. Are you ready to become one of them? Join us for a 2-year multidisciplinary master's program and find your expert role in the transition to a sustainable economy. We are Maastricht University, the most international university of the Netherlands. We are a student-centered university, which means that quality education is our top priority. Education within the Bio-Based Materials program takes place in a research-rich environment. Teaching staff largely comes from the Aachen Maastricht Institute for Bio-Based Materials, or AMIBM in short. It is a leading research institute committed to the development of advanced bio-based materials. Research at AMIBM spans the entire value chain, From materials sourcing to production, and from the modification and processing of new bio-based materials all the way to innovative applications. AMEBM is located at the Brightlands Camelot campus, where the master's program is also taught. This offers you a lot of opportunities. The Brightlands Camelot campus comes equipped with state-of-the-art research facilities. The campus houses research institutes, industry and education. Perhaps you will even meet your future employer. Studying with us means you'll not only be in direct contact with researchers, but you'll also be taught by them. Our lecturers work at the cutting edge of science. They are active researchers in areas like organic chemistry, polymer physics, and biotechnology. Apart from our close links to industry and research, students appreciate our small-scale education. Each of our students has their own academic advisor, who provides guidance and advice on personalizing your curriculum. Your advisor is also an active researcher in the field. He or she stays with you throughout the master's program. Our curriculum distinguishes itself through our unique teaching method, a combination of problem and research-based learning. Problem-based learning, or PBL in short, lets you solve challenging problems in each course. It stimulates active learning and improves collaboration in multidisciplinary groups. Research-based learning, or RBL, allows you to solve complex research challenges set forth by academic or industrial partners. You tackle contemporary research topics as part of your studies. This is complemented with practical skills trainings, which are incorporated into the courses. The combination of these elements is what makes our program unique. But that's not all. Professor Yvonne Vandermeer is one of the program's founders. She will tell you more.
You can learn about biology, about the applications of materials, also a bit of entrepreneurship and sustainability. So you get a complete picture of bio-based materials and not one aspect in particular. So that gives you a broad view on the whole development of bio-based materials, from resource to material to applied products.
Our multidisciplinary program is based on 3 disciplines: biology, chemistry, and materials science. You'll take courses on all of these topics, supplemented with courses on the application of bio-based materials. Here's why.
We teach combination biology, chemistry, and material science because we conduct a so-called value chain at our master program. So first block in this value chain is biology. Why biology? Because students need to know biology because they need to work with biomass and they need to know how to deal with biomass and how to extract from this biomass valuable products. Then you need to know, if you have already the building blocks extracted from biomass, you need to know how to synthesize further. And now we are coming to knowledge of chemistry. Having these monomers or building blocks, then students need to know how to make new materials from these building blocks. For this, they need to learn how to test these materials, how to improve mechanical properties of these materials. And finally, the final block in this value chain is application. Because you have already new material, students need to know how to bring this new material to the market and what kind of economic impact this material will have and how to assess life circle of this material.
Here you can see a rough outline of the first year's schedule. You can only start the program in September. Each year consists of 2 semesters, which are divided in 3 periods each. In the first 2 periods, which last for 8 weeks each, you take compulsory courses. This will give you a basic understanding of the main disciplines. During the courses, you'll spend about 20 hours a week on lectures, tutorials, and skills training. The remaining 20 to 24 hours are spent on independent study. After the courses in the first 2 periods of every semester, you work on a research project for 4 weeks. During research projects, you work as a group with around 7 other students. You solve a real-world research challenge using the knowledge you've picked up from the courses and skill classes. Just like in real life, everything from the research to the reporting and project management is in your hands. You'll spend the full 40 hours of the week on this research project. One of our lecturers will tell you some more about the research projects.
students have an opportunity to translate the knowledge that they received during the previous courses or compulsory course of previous study to practice their skills during this research-based learning project period. Example which I can mention for the project periods could be that students extracted keratin from the sheep wool, and they made keratin-based hydrogels for carbon dioxide capturing. Also, they tried to mimic slime, which is released from hagfish, for example. So they made keratin-based sort of slime for biomedical applications. Last time, they also extracted very valuable antioxidant from the grape skins and grape seeds, resveratrol. And as we know, the grape skins and grape seeds are main waste in grape processing industry.
From the second semester on, you choose the courses you want to follow. This lets you pick your own specialization. You will follow the courses of your choice during 2 periods of 8 weeks each, which is finalized with another research project. The second year starts with 8 weeks of elective courses. These are followed by an internship and your master's thesis. Your master's thesis is the most important project you will take on. One of our lecturers will tell you more about the final thesis project.
There are many examples of master thesis projects. Bio-based materials could be made for different kind of applications, for example, biomedical applications, and we had the projects where students made different 3D printed new materials, PLLA materials for tissue engineering, of bone engineering, or they made new bone implants. Also, it was studied biodegradability of the materials. During one of the projects, students made also life cycle assessment of certain materials. So the master thesis projects are very broad and wide in the topics.
As you can tell, the curriculum is flexible. Will you obtain more in-depth biological knowledge, expand your chemistry skills, or dive deeper into materials science? Through our elective courses and diverse research project opportunities, the choice is yours. If you would like to know exactly which courses we offer, please download the brochure on our website. Graduating with a master's degree in bio-based material is just the beginning. Challenges in the field of bio-based materials will change our collective future for the better. As such, the labour market's demand for bio-based materials scientists continues to grow. Some of our graduates dive straight into a career, others choose to pursue a PhD, and yet others start their own business. Our alumni work in a variety of fields ranging from industrial to academic research and from biotechnology to chemical and polymer engineering. The types of jobs you can get are equally diverse: application technologist, research engineer, research development scientist, or entrepreneur. The future is yours.
While students who want to enter our program can come from various backgrounds, so that can be biology, chemistry, material science background, because in the program you can add some expertise that you didn't have in your bachelor's program. At the same time, we look for students who want to get the broad view on bio-based materials, so not only look at one expertise, but are interested in more than one. And also students who take their learning experience very proactively, because our program is student-centered, it has a high quality, but it also requires that students take a lot of effort in that journey themselves.
Our master program is good fit for students with background of chemistry, biology, material science, engineering, of bioengineering, technology, biotechnology. So students with different kind of backgrounds can apply to our master. Most importantly, you need to be open for challenges, you need to be motivated, and you want to learn problem-based learning.
Are you excited to start this program? To enroll, you need a bachelor's degree in a relevant field such as material science, chemistry, biomedical engineering, or biotechnology. Most importantly, you need motivation. Motivation to study across disciplines and to be challenged academically. Our master's program is taught in English, which means proficiency in English is required as well. Every application is individually assessed by our Board of Admission. Finally, you should know that if you're a student coming from outside of the European Union or European Economic Area, we ask a handling fee for processing your application. But this money is not lost. When you come to study with us, the handling fee will be refunded to you. Details on the registration and admission procedure can be found on our website. We'll leave the closing words to our Director of Studies.
Thank you, and I hope we get to see you in one of our online events or here in Maastricht.
Thank you.